Data structures. Data structures is a way of storing and organizing data in computer memory so that it can be used efficiently. It's a way of arranging data on a computer so that it can be accessed and updated efficiently. So data structure is a specialized format for organizing, processing, retrieving and storing data. The data structures can be classified into several types. The data structure can be classified into primitive and non-primitive data structures. Primitive data structures are nothing but they are having the basic data types. All the basic data types belongs to primitive data structures. The basic data types like integer, character, float, pointer, real and boolean belongs to primitive data structure. Non-primitive data structures is further classified into linear and non-linear data structure. Linear data structure shows the relationship of adjacency between the elements. Further, linear data structure is divided into static and dynamic data structures. Array is an best example for static data structure. Array can be classified into one-dimensional array, two-dimensional array and multi-dimensional array. In dynamic data structures, stack, queue, linked list or these data structures are coming under dynamic data structures. Stack is nothing but it's a specialized data structure for it has only one end called top of the stack in which elements can be inserted and deleted at only one end called top of the stack. Stack is otherwise called as LIFO list, last in first out list. Queue is a linear list. It has two ends. One end is called front and another end is called rear. In rear end, insertions can be taken place at the rear end and deletions can be taken place at the front end. Queue is also called as FIFO list, first in first out list. Linked list is it's a dynamic data structure. It has a special structure for storing elements. That special structure itself is called a node. The node has two fields called data field and link field. The data field contains the data which is to be stored and the link field points to the address of the next element in the linked list. So linked list can be further classified into singly linked list, doubly linked list, circular linked list. They all belongs to dynamic linear data structure. Tree and graphs are examples for nonlinear data structure. A graph G can be defined as a graph G equal to V comma E, where V represents the set of vertices and E represents the set of edges. A directed acyclic graph is a tree. A directed acyclic graph is a tree. A tree has a special node called root node whose in degree is always 0 and out degree is less than or equal to n. If n's value is 2, then we call the tree as a binary tree. The operations performed on these data structures are searching, sorting, insertion, deletion and updation. Searching. We can search for any data element in a data structure using search operation, and we can sort the elements in the data structure in either or ascending or descending order. We can insert new data elements in the data structure. In all these data structures, primitive as well as non-primitive data structures using insertion operation, deletion operation. We can delete the data elements from the data structure using deletion operation. Updation. We can update or replace the existing elements from the data structure using updating data structure. Advantages of data structures. These data structures allow storing the information on hard disks. Data structures are necessary for designing efficient algorithms. It provides reusability and abstraction. Manipulation of large amounts of data is easier in data structure. Thank you.